I am out today for a meeting at the county office, so you get to listen to my voice. Isn't that awesome? So, please do have your warm-up books out and copy this warm-up down. And you might want to pause the video while you do the warm-up, but I will go on and explain the warm-up as if I was there. So this first question is from quiz 2. And the second one is from quiz 1. Remember, to start studying for your test, you should study notes and warm-ups, quizzes, homeworks, class examples. So notice that I've given you f a parabola with a domain of all real numbers, and g, which is a radical, which domain means you can't have no negatives under square roots. Nobody asked me about domain, but that's what I think of as soon as I see it. So notice this is asking me to find the composition at a number, and this is asking me to find the composition function, right? So those are things that run through my head when I see this question on like an assessment. So let's do the first one. F of g of 1 means go find f, but put 1 into g first. So g is 2 times x plus 1, so I put 2 times 1 plus 3. So now that's the function evaluated at a range value of g. 2 times 1 is 2, plus 3 is usually 5. Square root of 5 is not an integer, so I leave it like that. And now I go to f, and now that I don't have a function, I can just put the square root of 5 in for x and subtract 9. Do the order of operations. The square root of 5 squared is 5, minus 9 is negative 4. So now, let's go do the second one. The composition function means go find f and put every answer from g into it. Notice here I was able to put the 1 into g and get radical 5. Here I'm not. I'm putting every x that is legal into g and then taking all of those answers and putting it into f. So here I actually have to say, well, where would all those x's go? They would go in the place of x. X gets squared, and then minus 9. So into here, into place of x, I'm going to not put radical 5. I'm going to put the radical of every legal x times 2 plus 3. But just like what happened with radical 5 squared and I got 5, here I have radical 2x plus 3 squared, which just gives me 2x plus 3, and then of course minus 9. So I get 2x minus 6. Now, look what happens. That's for any legal x. Nobody asked me about the domain, so I don't have to answer that question. But notice what happens if now I asked you for f of g of radical 5. Because remember, this is now f of g of x is equal to 2x minus 6. Now what if I ask you for f of g of radical 5? I'm sorry, no, silly. F of g of 1, my bad. F of g of 1, you go to the rule for f of g of x, and I plug in 2 for 1, I'm sorry, I plug in 1 for x, and shocker, what do I get? The same thing. When I plugged in 1 to g, got radical 5, then plugged radical 5 into g, I was doing the composition once for one number, and I got the result -5. When I was doing f of g of x, I ended up with a rule for any x. So of course I could plug in 1 here and get the same answer. I would say that this way, if I just want the composition at one number, I would do it the first way. But if I was asked for the composition function, I don't have a choice. I have to give them 2x minus x, 6. Or if they want to ask me for f of g of 1, and then f of g of 2, and then f of g of -4, and f of g of 0, well, then I would go ahead and get the rule and plug and chug. Okay, so that's decision making. All right, so without a calculator, right, we will be doing some of these domain questions of weird functions with a calculator, but on the unit test, you're not going to have a calculator. So what is my thinking process here? I'm not thinking composition. They just want me to find the domain. So my domain is going to be all real numbers except, and then I go and I say except because I'm dividing. What is the bad issue with dividing? What you can't divide, what can't you divide by? So I need to find, that's right, I can't divide by 0. So I think to myself, what makes the denominator equal to 0? That's the only thing I'm worried about. Divide by 0 is my only worry. So I factor this quickly. And I find that the bad x's that create 0 are -3 and -1. Notice I don't make a number line. I'm not worried about negatives. I'm only worried about division by 0. So I'm only kicking out the numbers that equal 0 in the denominator. And -3 and -1 are fine in the numerator. But if you put -3 in this x and in this x, you get 0. Or if you put -1 in this x or this x, you get 0 and you can't divide by 0. Now notice I gave you an example of the next question, where this time I am not worried about dividing by 0. What am I worried about? Square roots not of 0, square roots of negatives. So I say to myself, the domain is all real numbers except the numbers that make that radical 0. I'm sorry, make that radical negative. So this time I start saying, what can make this value under the radical equal to 0? Because I can't solve for negatives. I factor. This time I have to make a number line because I'm looking for negatives. -4 creates 0, which is okay. 3 creates 0, which is okay. So then I test a number below 0, like -5, and I say to myself, what if this x was -5? -5 plus 4 is negative. -5, this x has to also then be -5. -5 minus 8 is also negative, and a negative times a negative is a positive. I test a number in between -4 and 3, like 0. 0 plus 4 is positive. 0 minus 3 is negative, and a positive times a negative is a negative. I test a number above 3, like 4, and put 4 in here for x. 4 plus 4 is positive. 4 minus 3 is positive, and a positive times a positive is a positive. So my domain is all where I generate positive numbers, which would be below and equal to -4, because 0 is not positive, but it's allowed under a radical, or x is greater than or equal to 3, because even though 0 is not positive, 0 is allowed under a radical. There's my domain. So the things that you should think to yourself are this. Self. Notice for the first problem I was only worried about division by 0. X was squared and I had to kick out 2 x's. When I was worried about negatives, I had a quadratic under the radical, so there were 2 numbers that created 0, and then I just had to worry about where my positives and negatives were. For those of you that get the graphical interpretation of this, remember any parabola with a leading coefficient that's positive starts out positive, is negative in between the x-intercepts, and then goes positive again. Ask yourself when that changes. Hint, it's when the leading coefficient is negative. Okay, so expect questions like this on your test. Now we're not going to do anything new today. We are just going to do some reviewing, but I'm going to throw you a couple of twists on the inverses. So you should have the substitutes should have a handout that you picked up like this. This is a very easy question, but it is a great test question. It really, without asking kids to do a lot of algebra or even computations, it really gets to the It really demonstrates whether a student has the concept, the number one fun fact of inverses. Sorry, I keep doing that. So, notice this is a graph of f. You say to yourself, self, this is a graph of the original. And on the original, I have x, comma, y. So for instance, look at this point. This point is 0, comma, what? 5. On which graph? The original. That's right. So if 0, 5 is on the original, this is wrong. Do not write this down. Do not write this down. It is not true that on the inverse graph, this is the inverse graph. It is not true that on the inverse graph, 0 gives you 5. That is true on the original graph. But what is the number one fun fact of inverses? If 0, 5 is on the original, what is on the inverse? Right? On the inverse, 0, 5 isn't there, but 5, 0 is there. So, look at these questions. When the inverse is 2, what is y? Oh no. When the inverse is 0, what is y? Oh no. When the inverse is -1, right? The x on the inverse is -1, what is y? Oh no. But look at this question. On the inverse, when x is 5, what is y? And you know why you know that? Because of the number one fun fact of inverses. If you see 0, 5 on the original, then 5, 0 is on the inverse. So can you answer the rest then? So in other words, up here, asking you for f inverse of 2, what does that mean? This 2 is an x on the inverse, which means what did it used to be on the original? If it's an x on the inverse, what was it on the original? That's right, a y. So go to where y is 2. Oh, looky. Y is 2. What is x then? 1, 2, 3. -3. So if the point -3, comma 2 is on the original, on the inverse, when f inverse is 2, what is y? Woot! If negative 3, whoops, I did that wrong, didn't I? If negative 3, 2 is on the original, then 2, negative 3 is on the inverse. So can you do the, so up here, negative 3. So can you do the next one? What's the trap on this? The trap on this is to say 5, right? But you're not looking at where the inverse was x. If the inverse is x, what did it used to be on the original? A y. Where is y 0? Y is 0. Oh, here's a point where y is 0. What is x? 1, 2, 3, 4, 5, 6. So on the original, there's the point negative 6, 0. Number one fun fact means that on the inverse, when x is 0, y is negative 6. And the last one, this is an x on the inverse, meaning on the original it used to be a y. And sure enough, here's a point where y is negative 1, x is 2. So if on the original, 2 goes with negative 1, on the inverse, negative 1 goes with 2. So see that? There was no math, no algebra, but a really good conceptual question. Star that. Put this in your notes, please. Or you can put it on the back of that sheet if you like. I just gave you. So looky here, can I tell you that this messes with kids, and you've got to expect this on AP and IB tests. Sometimes there's going to be notation that you don't get, that you saw maybe a long time ago, or maybe even you never saw, and you're supposed to read in context and figure this out. So look at this, right? What could they possibly be asking? Certainly, I hope you recognize this. Why can't I change my color? There we go. I'm desperately trying to change my color. Come on. There we go. I recognize this. I can at least do that, and they did ask me to graph the function. So I can do that. Plus x squared plus 4. 1, 2, 3, 4. Nobody asked me to label, I'm just doing it. And then I say, what the heck is this? Question mark, question mark. Well, what have we been doing? We have been chopping domains, right? See this polite pause? That means here's the function you're supposed to graph. This is the domain they want you to graph on. This is just weird function notation. It says there's a function that uses x, and how you get the y's is putting x into the following rule. So I read this as f of x is equal to x squared plus 4. So just it's just notation, and even if you didn't know what it was, you probably could figure it out. Now I say to myself, uh-oh, crap. I graphed that domain on all real numbers. What is the domain value that I have to start with? And then what do I get? 4. How about when you plug in, I'm allowed to go above 0, so I plug in 1, and I get 5, and 2, and I get what? 8, right? So which piece of this parabola are they amputating? Right? This has to disappear because they chopped the domain. I'm only allowed to start at 0. Negative 1 doesn't exist for me, so this graph doesn't exist there. So I'm going to erase all of this and start again. x squared plus 4 does start here at 0, 4, but then is at 1, 5, and 2, 8. One arm of that parabola. So check, I graphed the function. Now I need to graph its inverse. Well, if I'm not sure what it looks like, remember, the number one fun fact of inverses is that a graph is going to be symmetric across the line y equals x. No, that's number 3 fun fact, isn't it? The number 1 is switch the x and y. So if 0, 4 is on the original, 4, 0 is going to be on the inverse. 5, 1 is going to be on the inverse. 8, 2 is going to be on the inverse. Label points if you're asked. If you're not asked, it's a good habit to get into so that the grader knows you know what you're doing. Notice those two fold across the line y equals x. So I graphed it. Oh, look, they did ask me to label. And that label means they're asking me to label both, so I put some labels on both. Determine the domain and range of the function. Well, hello, they gave me the domain of the function. There's the domain, right? So f of x has a domain of x is greater than or equal to 0. That was given to me. Duh. Ooh, I should have done this in purple, shouldn't I? Right? F of x has a domain that was given to me. Duh. Can you tell me the range of this? What's the first range value that's used? The first y value that is used is, that's right, 4. I use 4 and I go above. What's the number one fun fact about inverses again? Switch x and y, so I don't even need the graph. I don't even need the graph to find the domain and range of the inverse. Domain goes with x, domain range goes with y. Switch x and y, so the domain of the inverse is the old range, and the range of the inverse is the old domain. Now go look at the graph and see, is that true? Is the first domain value I use 4? Check. Is the first range value I use 0? Check. This is a great question. So I have found the domain and range of the function. They didn't ask me to find the domain and range of the inverse down to here until this problem, but I already have it. Why not? If I'm going to give you the domain and range of the function, I might as well give you the domain and range of the inverse because it's a simple switch. So what's the only thing I haven't done? That's right, found the equation of the inverse. So, again, number one fun fact of inverses, I'm going to turn this into, I'm going to do this up here, right? This is a y. Y is equal to x squared plus 4. Switch x and y. Get y by itself. And here's the part you're going to think is silly, but I'm telling you, I'm going to get you if you don't do it. I'm going to use the reflexive property to write y squared is equal to x minus 4. How many things can you square and get x minus 4? 2. That is the top and the bottom arm of a sideways parabola. However, because of my original chop domain, which arm of the inverse did I keep? The top or the bottom? Yes, I kept the top, and top goes with plus. So my final answer, equation of the inverse, I can use inverse function notation because I cut off the one-to-one problem of the original, and it is the positive square root of x minus 4. If you don't write the positive, you're fine. That's right. Positivity is assumed, which is a good lesson in life. However, if you don't get in the habit of doing it, if I ever give you the bottom arm, right, just the bottom arm, you might forget to put the negative in front of the square root. So remember, if I had given you the left arm of the original, the inverse would also have a bottom arm, and the inverse would not be a function. If I had only given you the bottom arm, this domain would have looked like this, the original domain, and the inverse would not have the top arm, but would have the bottom arm only, and then the equation would have been negative the square root of x minus 4. Crazy, right? So look at this one. Wait a second, didn't we just do this problem? But notice there is no domain given. If there's no domain given and there's no radical or division, what is your domain? Your domain, and this is why I don't like to put all real numbers sometimes. It is from negative infinity to infinity, right? So I go to 4. This function is not 1-to-1. The domain is negative infinity to infinity. What's the range? What's the first range value you use? So the domain and range of the original function, it's a parabola that opens up, so its domain is all real numbers, and its range goes from the vertex up. I'm going to skip this and go here. What is the domain and range of the inverse? Number 1 fun fact. The domain of the inverse is the range of the original. The range of the inverse is the domain of the original. I think I meant to ask you to graph the inverse here, so I don't have that in an equation, but let's go ahead and graph it. 1, 2, 3, 4. 4, 0. Remember we had the point from the last slide, 1, 5. So I have the point 5, 1, and 5, negative 1, right? Because on here is 1, 5, and negative 1, 5. We have 2, 8, and negative 2, 8. The inverse is not a function. Since you had the right and left arm, you have the top and the bottom arm. Now let's find the equation of the inverse. Y was originally equal to x squared plus 4. Switch x and y for the inverse. I'm going to use the reflexive property right away. You have 2 arms in your graph, therefore your equation must have the top and the bottom arm. And you may not use inverse function notation. Right? I can't use inverse function notation. Because I was not one-to-one. So this handout that I want you to do for homework and finish up from homework, I'm going to do a couple of them with you. But first, I want you to notice that I'm giving you that every equation is number 1, is one-to-one. You are welcome. You don't have to worry. Every function I'm giving you is one-to-one. So notice I also gave you domains, you know, in order to make it one-to-one. Whoops, sorry. So for instance, look at number 4. Number 4, this is not one-to-one. It's not one-to-one. Oh wait, polite pause. This is the domain that I've given you. This notation means you're only using x's less than or equal to 3. So you are supposed to know this parabola is at 3, 0. So talk to me about which arm I have. If I'm only letting you graph from 3 and below, that means that the right arm is gone. So you only have the left arm only. That means your inverse is going to be a function, but will not have the top arm, right? What will it have? The bottom arm. Now I want you to look at this one. Nobody asked me to graph. Nobody asked me about domain and range. I know it's one-to-one because I was given one-to-one. I don't expect you to know that that's one-to-one, but I'm giving it to you. So let me show you how kids lose a point on this problem. So they switch x and y. They say, not a problem. I know how do you get rid of a radical. They're going to square both sides. So that leaves them with x squared is equal to y plus 6. They'll get y by itself. Then they will dutifully change this. They're like, oh, that's right, I'm not going to lose a point. Ms. Getz told me that the original function was one-to-one, therefore I am guaranteed by the number, 4 fun fact of inverses, that the inverse will be a function. They circle this, woot, woot, woot. They're very happy with themselves. They turn it in and they get it back from me, and I have this on it. -1. Why? Why? And I will tell you, there's nothing wrong with the algebra. Nothing. And there's nothing wrong with the inverse notation either. Why is there a -1? Letting you think. Think, think, think. This goes back to quiz 1. Look at number 5. Nobody asked you for the domain, but you know how to find this domain. Now I know I said I gave you their domains, but that's if I gave you the domain to make the function one-to-one, right? This function has a problem. Where is the domain allowed to start for this problem? -6 generates what? 0. Can you put -7 in for x? No. Can you put -5? Yes. So the domain of this function is x is greater than or equal to -6. What's the range of this function? Look at the table I made. What's the first y value I got? 0, right? And then I got 1 and above. What's the number one fun fact of inverses? Domain and range are switched. What is the natural domain of x squared minus 6? 2 arms. Right? 2 arms, a domain of all real numbers. In order to have this equation represent the true inverse of y, its domain, polite pause, is the range of the original. OMG. That's deep. Now, that is a twist question. Not every question is going to be like that. You might lose 1 point by not realizing that. But that's why you practice with the easy questions, right? That question tests quiz 1 domain, number 1 fun fact about inverses, and function notation, right? All in one question. And maybe you miss one because you've memorized switch x and y, but do you really understand that switch x and y, what it does graphically and what it does to the domain and range? Crazy, right? Oops, sorry. I also wanted for you to look at number 3. Number 3 is kind of crazy. So I already told you it's 1-to-1. You are supposed to recognize the domain, right? The domain already has an issue, right? X can't be 0. So let's see what happens when we find the equation of the inverse. Remember I taught you a trick. If the variable you want is in the denominator and there is no other operations to do, you can just reciprocate, right? There's no adding and subtracting in separate functions. Reciprocate the left side as long as you reciprocate the right side. Get y by itself. Y is being divided by 4. How do you get it by itself? Multiply by 4. Use the reflexive property, and remember that's actually 4/1. So, hey, wait a second. Still true that x can't be 0, just like it was for the original, but wait. 4/x is its own inverse. What? That's wacky. Check this out. Let me show you. Now, this is not something I expect you to know. Now, I expect you to be able to do that algebraically. I don't expect you to know what the graph of 4 minus x looks like. But this is what it looks like. And look at the symmetry, right? that graph right? This branch, part of the positive branch, reflects exactly onto the smaller part. This part of the negative branch reflects exactly onto this point, right? Wow. That also means that if you compose 4 over x into itself, darn it. If you compose 4 over x into itself, so y of 4 over x equals 4 over x and you put 4 over x into itself, 4 divided by 4 over x is the same as 4 times what? If you compose one function into another and you get x, what do you know? Therefore, you have inverses OMG. When you did algebra and you found the equation of y's inverse, you got 4 over x. When we graphed 4 over x, we could see the symmetry of y equals 4 over x was symmetric to itself across the line y equals x. And then when we did composition and put 4 over x into itself, x came out. OMG. Math is cool. Math is cool. Okay, so finish this practice. Remember, tomorrow you have an IB problem with partners. I pick your partners. And we will then also do a guided reading from IB that talks about all the stuff about inverses and composition that they're going to test you on. We'll go over that. And there will be no homework tomorrow. I will give you some guided reading questions, but that won't be due until Friday because you should be getting ready for your test on Thursday. Remember, no calculators. And remember, you should only feel like this, right? The only people that should feel like this are the people who didn't start to study until Wednesday night, okay? You should have been studying before that. All right, have a great day, and I will see you tomorrow. Trying desperately to stop this.